we need to get this field interact with electromagnetism. Okay, that is my goal for today's climax. Okay, the Higgs will be connecting with the electromagnetic field. So, we need to first write down the electrodynamics in terms of proper variables. Okay. You write with E and B, right. I mean that normally that is what we write, electric field and magnetic field, but that is not what is common in quantum field theory or in field theory. Field theory, what is more important is 4 potential. So, we are doing right now relativistic. So, this is so 4 potential is, you may know, phi and vector potential. The 4 components, first is the scalar potential and next is A. Okay. So, I have no time and no energy right now to tell lot about electrodynamics, but this is called covariant formalism. Okay. I am not sure whether you have done in your course, but we will just look at some of the forms which appears in field theory. So, first mu is a 4 potential with first component is phi and the third other 3 are A, like dt and dx. No? So, they are 4 vectors, energy and momentum, the 4 vectors. Then we define the tensor called F mu nu. Okay, you might have heard of this F mu nu, which is del mu A nu minus del nu A mu. Okay, these are partial derivatives. Okay, and how many components this F mu nu has? 16 components. Right? Mu goes from 0 to 3 and nu goes from 0 to 3. Now, if you work them out, it is not difficult. So, we get this matrix of this form. So, we have 3 electric field, well electric field here is a B sitting here. So, this is the 16 component. So, F mu nu has electric and magnetic field as a component, is a tensor. Okay, it is an antisymmetric tensor, and it turns out you will see very soon the coupling is I am going to show you the coupling. What is coupling? The interaction between. So, we have free electromagnetic field, we have free matter field like which is phi. Now, how to couple them, right? You need interaction, and that is what we are after, right? Electron and photons, how do they interact? Okay. So, I will write down the formula for that. So, this is a Lagrangian for free electromagnetic field, okay, B squared minus E squared, and the Maxwell equation is derived like that. So, take the derivative of F4 tensor and then I will get mu naught J. So, this has it covers two Maxwell equation. Del dot E is 4 pi rho and curl of B is 4 pi J by C plus or minus C squared E and C okay. I hope my sign is right. Okay. This equation, these two equations what we write is covered here. Other two equations which are constraints in fact, del dot B is 0 and curl of E is minus dB by dt. So, this should be plus, I think, right? This is plus or minus? Well, let us keep it. So, this equation, this should be plus actually, this should be plus, otherwise wave equation will be a problem. So, curl of, so these two are constrained and there are certain equations called Bianchi identities. Okay. So, these are all can be derived in terms of F mu nu, and it is a bit of algebra, but it is a very nice algebra, setting point for covariant electrodynamics. Lagrangian, that is what we need now. So, Lagrangian coming from the electromagnetic side. So, these are Lagrangian I told you about, This is a free Lagrangian for the photons, okay, which is E squared minus B squared, right. E squared plus B squared is total energy Hamiltonian, but E squared minus B squared is a Lagrangian, and this is the interaction. Now, are you happy with this J mu mu? A mu is the electric field and J is the current, okay, and it looks fine, because for charge particle q phi is a potential energy, charge multiplied by potential. So, this is J 0. So, J mu is my current, and what is the component of J mu? Charge density and current, right, that is a thing, and A mu is, I wrote before, phi and A. So, take a dot product of these, then that is why we get the interaction, which is we already know, okay. So, J dot A and rho times phi with a minus sign will come, okay. Now, please note that this Lagrangian has no term of the form m squared a squared, right. This one is del mu a nu minus del nu a mu, same thing with a superscript. So, where is the term like m squared a squared? None, right. So, that means the free particle, which is photon, has 0 mass. Okay. So, this is by construction, of course. Photon has a 0 mass. And one more constraint which is comes in electrodynamics is, for given wave vector k in Fourier space, I could have 3 components for A, right. If I do Fourier transform of this vector A, then I can have 3 components, but it turns out we have only this component, the longitudinal component is 0, okay. So, longitudinal component is 0. So, we have 2 transverse component, and these are the polarizations, okay. Right circularly, left circularly polarized, or it is polarization in this way or that way. We do not have polarization of photon along the k vector. Okay. It follows from mathematics. Okay. So, photon has two independent particles, one this way, another one this way, but not along that, this is not allowed. And action is this, which is I just integrate Lagrangian with the d4x. Okay. So, this is connected with electromagnetism. Okay. Now, so gauges. Now, gauge we are all seen in electrodynamics. No? So, this vector potential A or phi, they are not unique. What is unique is the electric field and magnetic field, right? Okay, which is B is curl of A and E is gradient of phi minus grad phi. So, in phi I can always add a constant. So, in phi in covariant formalism it is d by dt 1 by c. Okay. So, we can always add something so that my B field remains unchanged. In A I can always add gradient of a scalar. No? So, because curl of gradient of a scalar is 0. Okay. So, since my interaction, so please note that what participated in the interaction was J mu A mu. There was no J coming with electric field or magnetic field. So, in quantum mechanics you may know that what we work with is A, not E or B, right. So, Aharonov-Bohm effect, right. So, that A is important quantity. So, there are some subtle things. So, A is the central object. Okay. So, now let us look at the Lagrangian and how to write the Lagrangian, which contains both matter field and the electromagnetic field and interaction. So, it is written in a called minimal form. So, this is a minimal form. So, this is part is we already saw for the free photon field. Now, I am doing only 5/4 theory, okay. Right now I am not doing QED, Dirac, so I am doing only 5/4. So, this part you have seen it already for the scalar field. Now, in this some of it is you may recognize, right, del mu psi dagger, del mu psi, this is what I wrote before, no. So, what changes did I bring? I have added minus IQ A mu in the left and plus IQ A mu in the right. So, my derivatives are replaced by derivative plus or minus IQ A mu. Okay, Q is a charge of the matter field, okay, and M is a mu is the mass of the matter field. Now, is this object, what is symmetry of this object, this Lagrangian? It is an amazing symmetry. Okay. So, remember my psi, I have to make e to the power I alpha, alpha was constant, but now I can make alpha as a variable. Okay. But if I just make variable, then there was a problem, no, there was some subtraction had to be cancelled out. So, that I can absorb in A. So, the transformation, this is very nice, that psi going to psi to alpha and A going to A mu minus gradient of alpha. So, if I do this, then my Lagrangian is unchanged. Okay, we can do it easily. So, let us look at this part. So, del mu will be, what will be del mu? Del mu psi, let us do del mu psi. So, del mu psi will be del mu psi, well I am basically psi prime call it, okay, this psi prime, psi e to the power I alpha, then take derivative of alpha, psi del mu alpha I e to I alpha, okay. What about IQ A mu? So, IQ, but remember A mu has to be also transformed, A mu has to be changed, you can't keep the same old A mu. So, what do I do? Old A mu minus 1 by q del mu alpha x, okay. So, and e to the power okay, so I am multiplying this, e to the power I alpha will cancel with the e to the power minus I alpha in the left. So, this part I can get rid of, right, I mean, because when I do the product e to the power minus alpha will go away. So, not plus, I had add, I am making a mistake, not multiply, plus. So, what happens to this term psi grad alpha and this q will cancel with this, is a minus I, this exactly cancel that, got it. So, we get back the original gradient operator, the derivative operator with multiply by e to the I alpha, but if I do to the left guy, then I will get a same derivative operator, but e to the power minus I alpha out there. So, e to the power I alpha and e to the minus alpha will cancel and we get the same Lagrangian for this part. So, this is a very nice interaction term which preserves this symmetry. So, this is my gauge symmetry, this is in classical physics we know that this is important gauge symmetry, right. A can be replaced by adding a gradient of a scalar, and psi, this is also very important symmetry. So, my Schrodinger equation or this wave function psi, I would like to is independent of the phase, but of course, if I make it arbitrary, then I have to do something to A, it is not only one or the other. Okay. So, this is called gauge interaction because the interaction is determined by the gauge field. Now, this is for electrodynamics, people have done it for electroweak, this electroweak theory, and QCD. So, this is the cornerstone. Okay. So, this is called gauge interaction, that is like very big thing in particle physics. Even in condensed matter physics, superconductivity, we want this gauge invariance. Okay. So, does not change, or also it does not change E in B, right, because this thing will not change E in B. Okay. So, we have same electric field, magnetic field, same Lagrangian, but this is a transformation. Okay. So, now we are all set. The interaction term is okay, J mu mu. So, how do I see that J mu coming here? So, let me look at one term. Okay. Interaction term, what is this interaction term? So, del mu psi dagger and multiply with this IQA mu psi. So, this is a term, no, I have take this one, this derivative, multiply that. This one term is mu mod psi square. Okay. So, here, so what is this object? Psi del mu psi dagger multiplied by mu. What is this term? This is the current, no? Well, I have to add the complex conjugate psi grad. So, what is the current in quantum mechanics? Psi grad psi star minus psi star grad psi. Well, there is a I h bar by I or something. Okay. So, this is part of the current function. So, current is multiplied by mu and the coupling constant is q. Okay, is that clear? So, this is the current J mu mu. Okay. So, this is the gauge interaction. Now, we are going to look at Higgs after this.